Welcome. In this video, we'll go over the fundamentals of working with structured data to build predictive models. We'll begin by understanding the structure of our data and distinguishing between the response variable and the predictors. We will then discuss what prediction is and how it works, as well as the differences between regression and classification tasks. Let's dig in. Understanding the fundamentals of the data is crucial for creating predictive models. For the time being, we'll limit the scope to structured data. This refers to data that can be easily organized into rows and columns. The columns in a tabular dataset are commonly referred to as features. These are the variables or the attributes we are recording for each row. The rows are commonly known as observations, and they typically contain all values measured on the same unit or item across attributes. Whether it pertains to particular plant species, ecosystems, or conservation sites, each row should be distinct and ideally possess a value for each of the features. When it comes to predictive models, we first need to identify the variable we're trying to predict. Assume we're attempting to estimate the biodiversity of certain locations based on the age of the forest, the quality of its soil, and the average temperature in that area. In our example, we're trying to estimate the biodiversity of an area. We would typically refer to this feature as our response variable. The rest of the features will make up the data upon which our prediction is based. We call these data predictors. Now that we have a better understanding of the structure of the data, we can move on to what predictive modeling is all about. Predictive modeling is the process of using mathematics to explain the link between predictors and response variables, creating a model to predict future behavior. Consider our dataset and imagine we just have one predictor, say soil quality. In line with traditional mathematical convention, where X often represents an independent variable, we will refer to soil quality as X in our analysis. We'll then refer to our response variable, which is biodiversity, as Y. Now, every observation or row in our dataset can easily be plotted on a graph, where for every X, there is a corresponding Y. If we think about it graphically, a dataset is simply a collection of observations or a set of data points on a graph, where our predictor variable, or X, is placed on the X-axis, and our response variable, or Y, is placed on the Y-axis. Prediction is the task of identifying an optimal mathematical function that captures the relationship between X and Y. This mathematical function serves as a model, providing a framework that enables us to predict the outcomes of Y based on the given values of X. X and Y might have a simple relationship, like soil quality and biodiversity. In this instance, we're able to plot a line through the points and come up with a straight line equation that models Y as a function of X. This is comparable to the straight line graphs we created in early algebra studies at school. Depending on how we approach the problem, we could say biodiversity is equal to 1,900 multiplied by soil quality minus 9,000, or Y is equal to 1,900x minus 9,000. That equation then becomes our predictive model. In our example, our response variable, biodiversity, is a number. But as we know, we also get datasets with categorical response variables. For example, if we wanted to predict if specific species are present in a certain area or not, our response variable could then be yes, the species is present in that area, or no, it is not. The type of response variable determines whether we are performing a regression or classification task. If the response variable is numeric, we say that we are doing a regression task. To put it another way, we are trying to regress a number. If the response variable is categorical, we are performing a classification task. we say we are attempting to classify the observation into one of several categories. Considering our examples, biodiversity is numerical, and therefore the prediction task for this dataset would be regression. The presence of species in an area, indicated by yes or no, is a categorical variable, and the prediction task for that variable would be classification. It's worth mentioning that classification can encompass any number of categories. However, for our example, we specifically addressed binary classification, which involved predicting one of two possible classes for each observation. That concludes our discussion of predictive modeling for now. In this video, we looked at predictive modeling by distinguishing between predictors and response variables. We learned about predictions and how they work, as well as the differences between regression and classification. See you in the next one.